Okay, welcome back. This is section 3.2, polynomial functions. In this video, we are going to describe and evaluate polynomial expressions and functions. We are also going to describe the degree and end behavior of a polynomial and describe the number of zeros of a polynomial. Okay, so the first thing we need to understand is that a polynomial is an arrangement of coefficients and variables that create terms through multiplication, and those terms are then connected with addition or subtraction. Okay, so 4x cubed means 4 times x cubed, and that is a term. And then we're going to add that term to 3x squared, which is another term. Okay, so this would be a 1, 2, 3, fourth term polynomial. Okay, in standard form means that the degree is in descending numerical order. Okay. N has to be a non-negative integer. And all of the coefficients should be real numbers. So a polynomial in one variable is a polynomial that only has one variable, real coefficients, and non-negative integer coefficients. Non-negative or integer exponents. Sorry, I should have said exponents. Non-negative integer exponents. In general, the leading term is the term with the largest exponent. In standard form, it is the literally leading term. It's the first term that you write. Within that leading term, you have a leading coefficient, which is the number that is being multiplied to the variable. The degree of the function is the value of that exponent. So in this example, the degree of the function would be 3. It would be a third degree polynomial. You have two different types of degrees. You can have an odd degree polynomial, meaning the leading exponent is odd, which is this case. And then you also have an even degree polynomial, meaning the exponent on the leading term is even. Okay, so just some quick examples to kind of help get you in the habit of describing polynomials. This is a monomial. It has a degree of 0 because technically we have like an x to the 0 here, which is just 1. And the leading coefficient is the only number there, is 12. In this case, we have a binomial. We have two terms. The leading term is 4x. Its degree is 1, and its coefficient is 4. In this example here, we have three terms, so that's a trinomial with a degree of 2 and a leading coefficient of 5. In the next example, we have 1, 2, 3, 4 terms, so we call that a 4-term polynomial. It has a degree of 3, so it is a third degree polynomial with a leading coefficient of 8. Probably should have picked a different color there, huh? There we go. All right, so in general, we would say that this would be the leading term. It would have a degree of n, so it would be an nth degree polynomial with a leading coefficient of how we're going to say is a sub n. So that is a number that is the nth term of the polynomial. It's the coefficient on the nth term. Okay, so if we want to determine if a polynomial is a polynomial in one variable, or if it is a polynomial in one variable, what is its standard form, what is its degree, and what is its leading coefficient? Okay, so we check out this here, and we notice that it's either a constant or all in y. So it is a polynomial in one variable. So it is a polynomial in one variable. And to write it in standard form, we need it in descending order. So I look and I notice that my largest exponent is to the 6th. So I'm going to write that first. So this is 7y to the 6th. And the next one would be, after 6 would be 5. So that's negative y to the 5th. The next one down, 4, 3, here is y squared. So plus 5y squared minus 3y. And then 18 is positive, so plus 18. So this is a 6th degree polynomial, 6th degree, which means it is an even degree polynomial. I'm just going to say poly here. And its leading coefficient, so the leading coefficient is 7 because that's the coefficient on the leading term. Okay, let's try one more. In this case, they don't have things written out as terms. They have it written out as a factor. So let's go ahead and distribute this. So 2x times 4x squared is 8x cubed. And then 2x times 3 is plus 6x. And then negative 1 times 4x is minus 4x squared. And negative 1 times 3 is minus 3. And then to write that in standard form, we notice it has all x's or a constant, so it is a polynomial in one variable. And to write it in standard form, the highest degree is 8x cubed, and the next one down, minus 4x squared, and then plus 6x, and minus 3. So it is a third degree polynomial, and its leading coefficient is 8. Okay, in this example, everything, it looks like a polynomial in one variable, but then we notice that this is 4 over x. And if you remember, yet today or yesterday in class, we did, or the class before, we talked about the fact that 1 over x is x to the negative 1. So that means that this is not a polynomial that we can write in standard form. It is not a polynomial because it has a negative exponent. So we cannot write it in standard form. Okay, here we have a polynomial that also it has u and a t, so it is not a one variable polynomial. Okay, so how do we evaluate polynomials? Believe it or not, you have been evaluating polynomials since about 5th grade. When you started putting in numbers for the variables that you were learning about, you called it evaluating expressions, only now we're going to do it in terms of functions. So in this case, I'll give you a moment, please pause the video and read this paragraph. Okay, so we want to find the volume of air in the lungs 2 seconds into the respiratory cycle. And it already told us that T is seconds. So that means we are just going to simply substitute in 2 for T. So we're finding the volume of 2 seconds. And so that is negative 0.037 times T cubed plus 0.152 times 2 squared plus 0.173 times 2. Okay, so you want to make sure that you're showing this work because this tells me that you know how to substitute in the 2 for the t, and then go ahead and put that in your calculator, and you will find that the volume of air in the lungs 2 seconds in, so V of t equals 0.658, and remember it was in liters. So since it's a real world problem, we go ahead and write it in a sentence. Okay, take a moment to go ahead and try this one. Make sure you pause the video right now. Okay, welcome back. Here's your answer if you want to check it, and we'll also talk about it in class. Up next, what if the polynomial expression is not in the real world? So here, this looks like this is going to be a 2-piece polynomial, and we are going to fit it using this equation. Okay, so what this is saying is take 3c minus 4 and put that in for x. And then take c, put that in for x, and multiply the result by 5. So it might be easier if we take this one step at a time. So let's look at f of 3c minus 4. So just like we did above, we put 2 in for t. Here we're going to put 3c equals 4 in for x. So if I look at this equation, this says take your input and square it. So I'm going to take 3c minus 4, and I'm going to square it. Then this says take your input and multiply it by 2. So 2 times 3c minus 4, and then minus 3. So if we simplify to square this binomial, we end up with 9c squared minus 24c plus 16, and then I'm going to distribute here. So plus 6c minus 8 minus 3. Combine like terms, 9c squared minus 24c plus 6c is minus 16c, and 16 minus 8 minus 3 is plus 5. Okay, so this expression, f of 3c minus 4, is equivalent to this in this equation. Okay, so up next, we need to do 5, f of c. Okay, so that means I'm going to multiply by 5 the function when x is c. So in parentheses, c squared plus 2c minus 3. Go ahead and distribute the 5. So 5c squared plus 10c minus 15. And so that's my simplified form of this part right here. Okay, so now the next part says, now subtract those quantities. Okay, so I'm going to take f of 3c minus 4 and subtract that from 5 f of c. And that's going to equal, remember this one, so 9c squared minus 16, oh, that should be a c plus 5. And then subtract the entire quantity, 5c squared plus 10c minus 15. Okay, so 9c squared minus 5c squared is 4c squared. Negative 16c minus 10c is negative 26c. 5 minus negative 15 is 20. 5 minus negative 16 is 20. So f of 3c minus 4 minus 5 times f of c is this equation right here, 4c squared minus 2c plus 20. Okay, take a moment to pause the video. Go ahead and try this problem. It's done exactly the same way as the problem before, but we'll talk about it in class if you have any questions. Okay, so you should have gotten that as your answer. If not, that's okay. We'll talk about it in class. Okay, next up, if we remember from Module 1, we talked about the end behavior of a function. And we talked about the fact that if a is positive and n is even, then we're going to get a function that looks something like this, or, it could do all kinds of funky things. So as x approaches infinity, or sorry, negative infinity, so that means going that way, y is going to approach positive infinity. And as x approaches positive infinity, so that's going this way, y is going to also approach positive infinity. And if we flip a around, because remember when a is positive, it's facing up, so to say. If a is negative, then it's going to reflect across the x-axis. And so now we have these graphs that are going to kind of do these things where they start from negative infinity, they go around, they come back down. So as x approaches negative infinity, y approaches negative infinity, because as x goes out, y goes down. And as x approaches positive infinity, so that's going in this direction, what's happening? Y approaches negative infinity. When n is odd, we get graphs that more or less look like this. Now, they could do funky things, so they could look like that, okay? But overall, when the exponent is odd, okay, and a is positive, as x goes to this way, negative infinity, y is going to go down to negative infinity. As x goes to positive infinity, so this way, y is going to go up to positive infinity. And remember, we talked about what is x doing, or what is y doing as x gets bigger and bigger and bigger and bigger. If it's positive, what happens if x gets more and more and more and more negative? What's happening to y? Okay, well, what if a is negative here? We'll notice that it's almost the same, only it's reflected again across the x-axis. So as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches negative infinity. Okay, so let's do an example. If I were to describe the end behavior of this graph, I look, and as we're going to the left, this function is going down. So for part A, as x approaches negative infinity, so that means as the function goes off to the left, y is going farther negative. It's going down. Y is approaching negative infinity. As x approaches positive infinity, so that's going as the function goes to the right, okay, or as the graph goes to the right, the function is going up forever. So y is going to positive infinity. If we look at this, since these are going in opposite directions, this graph is going to represent an odd degree. So that is, the n needs to be odd because the graph ends down and then up, just as we talked about in the last slide. So according to the behavior of the graph, since they go off in opposite directions, this is an odd degree polynomial. And that would make sense because in an odd degree polynomial, when x is negative, y will stay negative. When x is positive, y will stay positive. Okay, and then we want to know the number of real zeros. Remember, the zeros of our function are where it crosses the x-axis. So here we see it crosses at 1 point. So the graph will have one real zero, and that's because there is one, that should say real, one x-intercept. Okay, go ahead. Try this one on your own. Make sure you pause the video right now. Okay, here are the answers. Please make sure that you're ready to discuss it in class if you have any questions. Okay, if you need some more examples, go ahead and watch some more examples video. Otherwise, go ahead and complete the 3-2 polynomial functions reflection. Up next, we're going to talk about how to analyze polynomial functions. Thank you so much for listening.